Hello, St. Paul class, and welcome to this edition. Here we're looking at Chapter 5, Section 1. We're going to be doing trigonometric identities and proving what the left side does and what the right side does and playing with all these different values. So let's have a little fun with it, and here we go. So looking at this very first problem, I want to be able to try to prove that this left side is equal to the right side. And remember, we said one of the strategies was starting off with the most complicated looking side, especially if there's only one thing on one side. Regardless of what that one thing is, we still want to start off with the side that looks more complicated. Well, and I want to be able to kind of rearrange these. Another strategy is trying to rearrange these everything in terms of sine and cosine. So I can think about that. Well, tangent, we know I can rearrange tangent, and I can, if I put that in terms of sine and cosine, so that's like sine of x over cosine of x. And I can say that cosecant is the same, so cosecant is the same as 1 over the sine of x, and I'm multiplying all that by cosine of x. Right? So at this point, you should already start to see, once I put it in terms of sines, I can see sine cancels sine, cosine cancels cosine, and so I do get the left side equal to 1, and we were trying to prove that that was equal to the right side. So there we go, first problem done. All right, this next problem, a little bit more complicated. All right, so I really want to think about this. How do I make these kind of equal the same? Well, I see a sine over here, I see a cosine. So I already kind of want to start thinking about possibly shifting these around. Well, if I change cosecant, I can change cosecant, we know, into 1 over the sine of theta. And then I've still got minus sine theta. Just once again, only dealing with the left side. If I'm dealing with this one side, I can't add or subtract these together the way they are. We don't have a common denominator. So there's another one of our strategies, right? Get a common denominator. So if I take this and I multiply by a common denominator, how would I do this? So I want to multiply both this by sine theta over sine of theta, and that will give me, sine theta in both top and bottom. So I have 1 over sine theta then minus sine theta times, so if I multiply those, sine theta times sine theta is sine squared of theta divided by sine of theta, right? So now that I have a common denominator, I can actually put those together. So what is 1 minus sine squared theta over sine of theta? Well, 1 minus sine squared of theta, based on, remember, rewriting our identities, is the same thing. So this 1 minus sine squared of theta is equal to what? It's equal to cosine squared of theta. And I still have in the bottom the sine of theta. Well, that's all for just the left side, right? So that's all left side. So in this problem, that still doesn't quite look like our right side. So sometimes we have to rearrange the right side as well to look like this. Well, I can say, well, I know what cotangent is. Cotangent we know is what? X over y. So therefore it's going to be cosine of theta divided by sine of theta. And if I multiply that by cosine of theta, what do I get? Cosine times cosine gives me cosine squared theta. And on the bottom I have sine of theta. And now I can see that, yes, left side equals right side. We did prove our identity. And so sometimes these problems do take a little bit of work. So this problem now, I should instantly already see 1 plus tangent squared of theta. The second that you start seeing squared terms, start thinking one of those three identities, what could they possibly be transformed into? Well, I'm going to leave the cosine squared theta alone right now. And I just want to transform this 1 plus tangent squared theta. Well, I know that 1 plus tangent squared theta is equivalent to secant squared of theta. Okay. Well, I can also, so put that in terms of sine or cosine. So I'm going to leave the cosine squared theta alone. And I can transform secant squared theta. We know that secant is 1 over cosine, so secant squared is 1 over cosine squared. So now I have cosine squared in the top and cosine squared in the bottom, so I just get 1 on the left side. And on the right side, we said that was supposed to equal 1, and we did prove, and that checks out. All right, this problem, well, remember when I said whenever, so one of the methods, is there any kind of, so if you have an add or subtract, we want to start thinking maybe, so there was a couple different techniques. We could think, is there a greatest common factor? So do I have any kind of greatest common factor between any of these? No. So greatest common factor is not an option, right? Can't do that. What about being able to split this adder? So remember, add or subtract, I can either split. So I can split this instead of being 1 minus cosine of theta over sine. I'm just going to put 1 over sine. So I can split that 1 over sine theta. And then I have minus cosine of theta over sine squared of theta. Once again, only working with the left side because that side looks a little bit harder to me at the start. Well, I know that 1 over sine of theta is equivalent to what? Is equivalent to cosecant of theta. And so I can change that. And I know that cosine over sine is equivalent to cotangent. So I already have this problem done. Cosecant. So on the left side, I have cosecant of theta minus cotangent. On the right side, cosecant of theta minus cotangent of theta. So we did prove that the left side equals the right side. So for this problem, I really want to just deal with just this left side because that's by far the more complex looking side. And I kind of want to start with this piece. The reason why, there's really no way I can do any kind of greatest common factor here. I don't really like this 1 plus sine t in the bottom because there's nothing there that you can do. There's no identity, it's not a square, it's nothing along those lines. So I'm kind of thinking in terms of like rationalize the denominator of what we've done before. So like when we did, if I had a square root of 2 plus 3 in the bottom, right? How do we get that out of the bottom? We had to multiply by the denominator, but switch the sign in between. So we're going to do the same process. So I'm going to multiply by the denominator, but switch the sign in between. So I'm going to say 1 minus sine of t over 1 minus sine of t. Now I can do that. I don't have to multiply by anything else because this is just multiplying by 1, right? So now I have tangent of t plus cosine of t times our new 1 minus sine of t. And when you multiply out the bottom, what happens? Well, 1 times 1 is 1. And since it's plus and minus, we don't have a middle term, and sine times sine is just, so this would be minus sine squared of t. Well, now that I have this squared thing, right, I can automatically start thinking identity. Do we have an identity that has a sine squared in it? Absolutely. So now I can say I got tangent of t plus cosine of t times 1 minus sine of t. And what the denominator, so we know that 1 minus sine squared is equivalent to cosine squared of t. Well, if I have a cosine in the top and a cosine in the bottom, we can cancel one of those out. So now I have tangent, but I'm going to change tangent to in terms of cosine and sine. So I know that tangent is what? Sine of t over cosine of t. And I can add that, then cosine t, so we get the cosine cancels out, right? So I have 1 minus sine of t over cosine of t because one of those canceled out. Now I can see I already have common denominator, so I can actually add those together. Well, sine t minus sine t just cancels. So I get 1 over cosine t. Well, I know that 1 over cosine t is equal to secant of t, and that's what I want it to equal, right? So now my left side does equal my right side, so yes, check. Approaching this type of problem, one of the strategies we can think about, remember changing all of these into um, terms of sine or cosine. And so I might want to think about that. We can't split this apart, so you can't like take the top over the bottom and cancel things out. I can't just automatically cancel secant out. I can't automatically cancel tangents out. That's against the rules because why? These are tied together, right? So I can't split the denominator into a part using that technique. So we can't split the denominator and do the top over the bottom split out. So I have to be able to think about other techniques, other terms. So if I change these into terms of sine and cosine, so I know that secant is equivalent to what? We know secant is equivalent to 1 over the sine of x. And right now all I'm dealing with is just this top part. Okay, and only on the left side is what we're going to approach for a minute. So 1 over sine of x, So approaching this type of problem, we want to kind of think already, we want to change this into sine and cosine. So I'm just going to focus on this top part over here right now. And if I change secant of x, I know that secant is 1 over the cosine of x. And I know that cosecant is the same as 1 over the sine of x. Now I can't add or subtract these together, right? They don't have common denominators. Well, how do I get a common denominator? Well, I kind of think about maybe like a cross multiply type deal. So this one, I need it to multiply by sine x because I need a sine in this side, and I'm going to put in sine x because otherwise I change the problem. And over here, I'm going to put cosine of x and cosine of x. So now I have, this just becomes sine of x, and on the bottom, what do I have? Sine x and cosine x. So sine x and also cosine x. And on the other side, I have cosine x, and on the bottom, we have sine x and cosine x. So that would be what this top part would become already. So I'm just going to think about that as being the top piece there, right? The same as that one. So now let's deal with this bottom piece here. So if I have that secant of x and plus cosecant of x, let's also change those, which is exactly the same. So you should already see it's exactly the same. The only difference is the sign is going to switch, but let's go through that process. Secant of x we know is 1 over the cosine of x, and cosecant is 1 over the sine of x. And once again, common denominators, so I can't have that. Can't add or subtract them the way they stand. So if I multiply this side by cosine of x over cosine of x, and I multiply the other side by sine of x and sine of x, so I get on the top then sine of x over sine of x times cosine of x. And over here I have cosine of x, and this is sine of x cosine of x. So now I have common denominators, so I can just add them together. So I have sine x plus cosine x all over sine x cosine x. And this would also be the same, sine x minus cosine x all over sine x cosine x. So what I want to do is just kind of put those two pieces on top of each other now and see what the heck is going to happen there. So I have sine x minus cosine x, and we have underneath that sine x cosine x, and we said we're dividing that, right, by sine of x plus cosine of x. So that would be what this piece is that we're dividing by, right? So we know this was our top or our numerator right here, and the green was our denominator. So I'm just dividing that out. And then this would be then sine x cosine x. Well, we know when we divide fractions, what happens? We keep change flip, right? So keep the first. So I get sine x minus cosine x. And on the bottom, I still have this sine x cosine of x. We change the sign to multiply and flip the fraction around, right? So sine x cosine x, on the bottom sine x plus cosine x. So I can see that those cancel out. So that all simplifies to sine x minus, so that cosine x over sine x plus cosine x. And this was our left side. So that was our left side of what we got. Now I got to go through the kind of the process to do that same technique on this side. So I want to take this tangent x minus 1. So I'm going to take tangent of x minus 1. And I'm going to change this into terms of sine and cosine. So I know that tangent is the same as sine of x divided by cosine of x. And that's minus 1. I can't add or subtract those together the way they stand, so I have to get a common denominator. So I have to multiply this side by cosine of x over cosine of x. And so I'm going to end up getting then sine of x minus cosine of x, right? Because I can add those together now. And on the bottom I have cosine x. So that would be what we had from the top there. So that's all that stuff from the top. Let's look at what does the bottom look like. So if I had tangent of x plus 1. So once again, I'm going to change the tangent of x to sine of x over cosine of x, and then plus 1. So I need a common denominator. So I have to multiply by cosine x. And so, but now that they have a common denominator, I can add these together. So this is just going to become now sine of x plus cosine of x all over cosine of x. So if that is our bottom and this is our top, so I know that I'm taking that and dividing by sine of x plus cosine of x divided by cosine of x. Once again, for fractions, you have to do what? Keep, change, flip, right? Keep, change, flip. So I have the first sine x minus cosine x all over cosine x. Change to multiply, flip your fraction, cosine x. This is now sine x plus cosine x. I can see that these will cancel out, and I will have sine x minus cosine x over sine x plus cosine x. And therefore this is our left side, this was our right side. So right, this was our left, and this was our right side. So do they equal? Absolutely. Checked and done. Right, so this type of problem would be probably the hardest type of problem I'd actually give you guys in class or on a test or a quiz. Pay attention. It does involve several different steps, but plenty doable. So what I want to do is automatically think, if I have secant 1 tangent, I can split this apart, right? So let's think about that and split that apart. So I can take secant of t over tangent of t, and that's the same, and then I can say then this is 1 plus tangent of t. And I'm going to rewrite these in terms of sine and cosine. So I know that secant of t is the same as 1 over cosine. And I know that tangent is the same as sine of t over cosine of t. Right? So I've done that so far. Now 1 over tangent is identical to what? We know 1 over tangent is identical to cotangent of t, and cotangent is the same, changing from into sine, terms of sine and cosine, is the same as cosine of t over sine of t. So what does this give me on this side? Well, what I want to show you, and we can rewrite that differently, and I just want to point out one thing. So if I have it 1 over cosine of t, and we're dividing that by sine of t and cosine of t, so I know that these flip, so I get 1 over cosine t times cosine of t over sine. So the cosines would cancel and just give me 1 over sine. All right? Little trick, whenever you have this like 4-part thing, it's always alternate. So I can see that this cosine would cancel this cosine and give me 1 over sine. So little trick there, it's alternating that would cancel out. Not someone side by side, but they have to be alternating. Because it's that concept of the denominator becomes the numerator and therefore cancel out. Right? And then over here now I have plus cosine t over sine of t, and I can now actually add those together because they have a common denominator. So this becomes 1 plus cosine of t is equal to sine of t. So that's as far as I can really go on the left side. So let's see what I can do now on the right side and see if I can come up with anything with that. So over here, if I'm taking tangent of t and secant of t minus 1, well, I can't split the denominator because it's tied to this negative 1, right? So I can't do that. But what we can do, let's think about that whole rationalize the denominator concept. So if I multiplied both the top and the bottom now by secant t plus 1 and secant t plus 1, what is that? So that's going to give me now then tangent of t times secant of t plus 1. And on the bottom, this would give me secant squared of t and then minus 1. All right. And remember what I've told you guys, the second that you see anything with this squared, start thinking, is there a possibility of having an identity? So let's just take our top, tangent t and secant t plus 1. What is secant squared minus 1 equivalent to? What is that equivalent to? Well, that's equivalent to the tangent squared of t. So I can see I can cancel out these tangents. All right, so one tangent on the top is going to cancel out one on the bottom. So I'm going to end up with having secant of t plus 1 over tangent of t. And now I can actually split this. And let's put them all in terms of sine and cosine though. But if I want to split this in half, so I know I can put secant of t over tangent of t and make this then 1 over tangent of t. Well, secant of t over tangent, so let's put this in terms of sine and cosine. Secant of t would be 1 over cosine of t. and tangent is sine of t over cosine of t. And that little trick, right? Alternates can cancel. So cosine cancels cosine. 1 over tangent is equivalent to cotangent of t, which would be then plus cosine over sine. So this gives me then what was left here, 1 plus sine of t. So 1 plus sine of t, and then this would be plus cosine of t over sine of t. And now that they are equal, I can add them together and give me 1 plus cosine of t over sine of t. And I can see that my left side does equal my right side. Those two are equivalent, so check, we proved the identity.